Okay, so we are we will be talking about how we can eliminate the null production and unit production. So, first we will check how we can eliminate the null production or epsilon production from a grammar. So, elimination of epsilon production. Okay. So, basically what we want? We have given a grammar G which is V T P S, where V is the set of variables, finite set of variable, T is the finite set of terminals, and P is the productions, that is also finite, and S is the starting variable. Now, suppose L of G suppose does not contain epsilon, then we can construct a grammar G prime which is V T P prime S such that there will be no null variable. I mean, there will be no null production in this grammar. Okay. There will be no null variable. Null variables means if suppose A is, suppose there is a rule A is going to epsilon, this A is called null variable, or it is the production is called, and A is called null variable. That means, we use this type of production to erase A. Suppose we want to erase A, so we use this type of production. Now, we do not need this, and also nullable means if some variable A is going to epsilon, then this called A is called nullable variable, nullable, which can be erased, like not only directly, if some more steps it is there. So, suppose we will take an example. So, we want to get rid of from this type of variables and this type of production from this production set. Okay. So, let us define what is the null production or epsilon production. A production of this form is called null production. Okay, and a variable is nullable. Variable A is nullable if epsilon can be derived from A by few productions, by applying few or more productions. So, if epsilon can be derived from A, then we call this A is nullable. So, then we want to omit all the null productions, because if our grammar is not accepting epsilon, then we can reduce the grammar by omitting all the null productions. So, then the theorem is telling if L is L of G, where G is the grammar, and epsilon does not belongs to L for some grammar, context free grammar G, which is V, T, P, S, then L minus epsilon, because epsilon is anyway not belongs to L. So, we can we are not going to derive epsilon from start state for start symbols or start variable is L of G prime for a CFG G prime with with no null production. So, that is the way we want to minimize our grammar. Ultimately, it will accept the same language, but we want to omit, we want to get rid of from all the null productions, because they are not going to contribute anything, because epsilon is not at all in the language. So, how we can do that? So, basically we are going to construct a grammar G prime, G prime like this. So, V t will be same, only the P will be different, the rules, I mean the transition will be different. So, for that we need to find the nullable variable recursively. We first find the nullable variable recursively, and then we construct the P prime. So, now the question is how to get the nullable variables recursively. So, this is the first step, construction of nullable variable, I mean the variable which are going to epsilon, I mean epsilon can be derived from those variables, those are called, that is A is nullable if epsilon is derived from A. So, that is then is called nullable. We want to find out all the nullable variables. Okay, so, we will do it recursively, like we form the W I is equal to 0. So, W 0, it is all the variable which are directly going to epsilon. This is the first step, this is we can say W 0. And then W 1, that means basically W I, or this is say W I say. Now, we are going to find the next one, that is say W 1, for I is equal to 0, I is equal to 1. So, W 1 is I plus 1 is nothing but W I, because they are already there, and suppose we put a variable in the a variable is nullable. Now, if a variable is going to that variable, or a string of a string of nullable variable, suppose B is going to some alpha, and alpha is consist of say some variable like A1, A2, AN, and suppose these are all nullable variable, they are already included in the previous W. Then we can say these are all going to this, that means B is epsilon is derived from B. So, that is the idea. So, this union with all the variables A such that there exists a production A is going to alpha in P, where with alpha belongs to W I star, with alpha belongs to W I star, because if these are all W I star, that if we know these are all nullable variable the previously, then B is also nullable variable, because this is B is having production like this and all are going to alpha, I mean few or more step, that means this is B is also going to alpha, epsilon. So, epsilon can be derived from B. So, this is the way we construct the nullable variable, and eventually it will converge. So, after some time we will see we have captured all the nullable variables. Eventually, we have this B k plus 1 is equal to B k, for some k we refer this as W k plus 1 is W k, we refer this as W. So, W consists of all the nullable variables, that means all the variables if it belongs to W, that means this property is there. Okay. So, now once we construct this nullable variable, then how to construct the P prime, the production, new productions. So, that is the step 2. So, construction of P prime. Okay. So, first of all, so this is a subset of P, this is a subset, this is a not a subset of P, this is coming from the production of P. Now, we take all the first of all we take all the productions whose right hand side does not contain any nullable variable. That means we take this in P prime, this is a belongs to, this is belongs to, we take this in P prime where, I mean this is in P because this is the production coming from this, and alpha does not belongs to W star. I mean alpha is not having any nullable variable, alpha is, so alpha we can write say A1, A2, An, and AIs are any AIs, any AIs, I mean some all the AIs. AIs are not belongs to W for all I. That means, we just include all the productions whose right hand side does not contain any nullable variable. That is the first step. So, this is any production in P will be added in P prime, any production of P whose right hand side does not have any nullable variable, have any nullable variable will be added in P. Is included in P prime. So, that is the first step. And the second one, now we consider all the such productions which are having no nullable variable in the right hand side. And now, suppose we have a production like this, A is going to x1, x2, xn in P. Suppose this is a production, and we know few are the nullable variable. If it is not, if none of these are nullable variable, that will come in the first portion. Now, if few of this is nullable variable, then we have to have the rule like this. So, what we are going to do? So, so this is we are going to do, we are going to add the production like this. A is going to alpha 1, alpha 2, alpha n in P, where in P prime, where alpha equal to x I, if x I is not a nullable variable, and then if x I is nullable variable, we will take this x I, and also we have another rule which is to erase epsilon, if x I does not belongs to, if x I belongs to W. We will take an example. So, suppose if x I does not belongs to W, if x I is not a nullable variable, then we will keep the x I as it is. Now, if x I is nullable variable, then we have two production, one is we keep x I and we erase x I. So, that is the thing, and not all alphas are epsilon. Okay. Not all alphas are epsilon. So, this is the rule we will follow to construct the P prime. We will take an example, then it will be more clear. So, we will take an example how to construct this, how to reduce this, how to reduce a gamma. Suppose we have given a gamma like this. We have few variable s, a, b, and terminals are small a, small b, and we have the rule like this: s is going to a s, capital S, capital A b, then a is going to epsilon, B is going to epsilon and D is going to B. So, S, A, B, D are the variables. Okay. Now, suppose this is given, this is our G. Now, we want to construct a G prime. So, first of all, we have to find the nullable variable. So, these are the variable which is directly going to epsilon. So, this will come into W 1 or W 0, whatever you say. If you start with W 1, then it is okay. So, W 1 is the all the variables which are directly going to epsilon. These are the W 1. Now, to construct W 2, W 2 will be W 1 and those variable which are going to some nullable variable or some string of nullable variable. So, like here S is going to A B and A B is nullable variable. So, S will be added here. So, A B S. Okay. And next we stop here because this will W 3 will be same. So, this is our W. Our W is nothing but A B S. This is our W. That is the set of nullable variables. Now, using this we want to construct a P prime, the rules, new rules. So, first of all we take the variables whose right hand side is having, we take the production whose right hand side is having no nullable variable. So, that is this is the one. So, that means B is going to this is the one we are going to add. So, this is the construction of P prime. Okay. Now, there is no such rule which is right hand side does not have any variable or which is nullable. So, now we take the rule like so this we directly omit this epsilon. So, now we take S is going to A S. So, this gives rise as to, so like as we said, if A is going to x 1 x 2 x n, then we are going to replace this by A is going to alpha 1 alpha 2 alpha n, sorry. So, there are few steps x I, if x I is not nullable variable, x I is not W, then we keep alpha I is not x I, this is alpha I will be equal to x I if x I is not a nullable variable. Otherwise, if it is nullable variable, we have two options, we can erase x I or we can keep x I. So, if you do that, it will give rise as S is going to A S, this is our x I and S is going to A. Okay. So, this is the two rules, these two rules will be added in this. So, we can erase x I, we may keep x I, that is the nullable variable. So, this will give rise as this, and the third one is S is going to A B, this is also give us what? This gives us rise two rules again, S is going to A B 1 and we can erase A B and then we can erase A. So, these are the production will be in P prime. Okay. So, P prime consists of this. So, this and this all this production will be in P prime. So, if we write this, so our G prime is we have all the variables S A B D and the terminals is A B and P prime and S, where P prime consists of D is going to B and S is going to A S or A or A B or capital A or capital B. So, these are the rules it is going. Okay. So, then we can show that this is eventually giving us the language L of G minus epsilon. So, that proof will be there in the lecture note. So, now we will go for the unit production, elimination of unit production. So, now we will go for the elimination of unit production. Okay, so, unit production or a chain rule in the G is a production of the form A is going to B, where A, B are two variables only, not the string of variables. So, these are called units production. So, for example, if we have a grammar like this, A is going to A, B is going to S is going to A is going to B, then B is going to capital C, and then say C is going to small a. Okay. Now, these are all the unit production. So, this is you can easily see these are all can be reduced further, because ultimately say C is reachable from C can be derived from S A B and C is going to this. So, this is straight away can be all these thing will be, because this is generating the same grammar like A. So, S is going to A, this is the only production can be represent this. So, this is called the, so we are eliminating all the unit productions and it will eventually give us the same grammar, but formally we will define that how we can do that. So, let us try to do that. So, we are going to remove all the unit productions, because we want to reduce the grammar. Okay, so, so we have given a grammar G. Then we have to find another grammar. So, first we remove the null productions and then we will go for the removing the unit production by this. So, for that for any variable we are going to construct a set of variable which is derivable from A. So, that is the step 1. So, that we denote by WA. WA is the set of variables which are derivable from A, and that we do recursively like this. So, obviously, A is derived from A. So, we put A first and then the recursively like this. So, WI A union of all the variable B such that C is going to be where C can be derived from A. If C can be derived from A, then B also can be derived from A. If C belongs to WI A, this is the recursive way we can construct this, and eventually we will see this will converge. This will convert and give us this. So, we will find all the variable W of A, all the variables, and then we will construct the grammar like this. So, let us first take an example, then it will be more clear. So, let us take an example. Suppose we have a grammar like this. C comma B and C is going to D, D is going to E and E is going to A. Okay. So, first we want to get a grammar which is after eliminating, we want to eliminate the all the unit production and get an equivalent grammar. So, for that what we do, what are the variable set? Variable set is A, B, C, D, E, S. So, this is the variable set. Okay. Now, first of all we want to find W of each variable. So, W of each variable. So, first of all we want to find this W of S. So, this is S, then S is A B. So, so W1 of S, these are the variables which are reachable from S. W1 of S is W0 S, and union of all the A belongs to this such that A is going to B, where B belongs to, sorry, this A or that A is mixing. So, this is x1, this is all x1, x2, where x2 belongs to Wi of S. So, that is null. So, basically this is S. Okay. Similarly, we can construct W of A. So, W of A, for this we can just write W0 of, and this will be again only A. We can find out this. Now, let us take one example where it will be more. W of B. So, these are the variables. So, W0 of B is B, and so W1 of B, it will be B union of. So, all the variables which are going to a variable which is derived from B. So, which is derived from B? So, C is derived from B directly, because B is going to C. So, in the first step it will be B C, capital C. Now, then W2 of B, so B C, and then union of those variables which are derived from derived from B, that means which will be going to any one of these. So, that means it will be D, because D is going to C, D can be derived from C and C can derive from B. So, it will be D. So, this will give us B C D like this, and if we continue this, ultimately E will be added, because once D is added, E is derived from D and D is derived from B. So, E is derived from B. So, that means in the next step E will be added. So, that means W of B is nothing but B, C, D and E. Okay. So, this way we will construct the derivable set. So, let us write all the derivable sets. So, W of S is only S, W of A is A, and W of B is this set, and W of C we can similarly find out C, D, E, and W of D is D, E, like this. So, we can get this W's. Okay. Now, once we get these W's, how we can get the P prime from here? So, the rule is, if we have so if we have A is going to alpha, this will be added in the P prime whenever B is going to alpha in P, I mean in G, such that B belongs to W of A. So, if B is reachable from A, and if we have a rule that B is going to alpha, that means eventually A is going to alpha. So, we can get rid of B, we do not need B. So, like this we will find the rules over here. So, if you do that, we will get the rules like this. Yeah. So, S is, so this is the production we are writing. S is going to A B, and A is going to A, B is going to B, E is going to A. Okay. This is the productions. Now, if B is going to A and C is going to A, D is going to A. This is because B is going to C and C is going to D and D is going to E, and then finally E is going to A. So, we can use this by, we can get rid of all this thing, and we can just write this E is going to A in G and this. So, this is the way we reduce the all the unit production in the from the grammar, from the reduced grammar. It will accept the, it will corresponding to the same language. Thank you.